Hello, this is session 3 of determining the equivalent capacitance of different arrangements. So let me write the title here. So it is determination of equivalent capacitance, and it is session 3. So in the last two sessions, we dealt with several of cases of determining the equivalent capacitance, and now a few more cases. So if we have this sort of arrangement here, let me draw the arrangement. So this is one capacitor, this is another capacitor, this is one capacitor, then no capacitor here, but here we have one capacitor like this. So if we have this sort of arrangement, what will be the total capacitance? So to deal with this case, so let me name the points. This point is A, this point is B, this point is D, and this point is A. So this is C1, C2, C3, and C4. So let us see here. This point B and D, they are common points. So what you can say is, the capacitor C1 connects directly from the left to the right. So if I draw it like this is point A. From here goes capacitor C1, which goes directly to a point which is common to both B and D, and it goes like this. And then from A, another capacitor goes like this, which is C3, and this goes to a certain point E. This point E is the meeting point from this side. If I see from this side, it diverges to this and meeting point of C4 and C2. So from E, we have this goes as C2, this is C2, and this goes as C4, this is C4. They meet at a common point, and this common point goes to BD. So I can consider this point also as BD. So this is the proper arrangement of this circuit. So from A, one goes to C1 and to BD directly. Then from A, one goes C3. From the point E here, it bifurcates to two capacitors and which join to B and D. So from here, what I can now do is, I can change this circuit to this form. So from here, we have got C1, which is C1 here. From here I have got a C3, and this capacitance here will be the parallel combination of C2 and C4. So it will be equal to C2 plus C4. Then this is point BD. So now this arrangement will be the series of C3 and C2 plus C4. So this will give us, so this is the capacitor, this is C1, and from here it will be, this is the series of C3 and C2 plus C4. So it will value be equal to C3 into C2 plus C4, and then C3 plus C2 plus C4 like this. Then lastly, at last, the final capacitance is the parallel of these two. So its value will be equal to, it will be C1 plus C3, C2 plus C4, then it will be, so it will be simply C3 plus C2 plus C4. Now if we have all the capacitors, all the values C, and C, so we can use the values here and find the equivalent capacitance. So this is a case of a complex circuit like this. Now if we have another capacitor like this, so this is, let us say, C5. So if we have such circuit, this circuit resembles a Wheatstone bridge, as is done in the electric circuits chapter. There we used to have resistors, and here we have got capacitors. And this circuit is similar to, this circuit is the same as this circuit. So if I construct a circuit like this, so here we have got capacitor, here we have got capacitor, and in the middle also I have got a capacitor. Here also I have got capacitor, and here also I have got capacitor. Now the naming will be, this is C1, this is C3, this was C2, this is C5, and this is C4. Now as in Wheatstone bridge, if we have by chance, if we have C1 is to C5 equal to C3 is to C4, then there will be no PD across here. So that means in such case, this branch will be useless. This branch will be useless. So I can rub it away. Now after rubbing it, the circuit is simply C1 and C5 are in parallel, C3 and C4 are in parallel, and those parallel combinations are in series with each other. So in such case, this circuit will become somewhat like this. So it will be like this and like this. So the upper capacitance will be equal to, so this will be equal to C1 C5 by C1 plus C5, and this will be equal to C3 C4 by C3 plus C4, and its equivalent capacitance will be it is simply like this. So it will be a parallel combination of these two. So this whole will be equal to C1 C5 by C1 plus C5 plus C3 C4 by C3 plus C4. So this is an example of Wheatstone bridge. Now Wheatstone bridge can also take some different forms. For example, if I have this sort of form, which is similar to somewhat we have dealt with previously. So if I have this form, so this is the series arrangement of 3 capacitors, and if I now connect this, not connect actually, if I use a capacitor here and if I use a capacitor here. So this thing is again a Wheatstone bridge. So this thing is the bridge here. So if I have this, I can name it in any case. So it is, let us say it is a C1, it is a C3, this is a C4, this is C5, this was C2. So in this case also it is simply Wheatstone bridge. So if I pull this point like this, pull this point like this, and pull this point like this, it will be, so let me say this is point A, this is point B, C, point D, and point E. So if I pull like this, let me pull D up and B down. So it will be D here, B here. There will be a capacitor between these two like this. So from here, from D goes C1 to A, and from A comes capacitor and up to B. So this capacitor is a C3. From D goes a C5 capacitor. Let me draw C5 like this. So this is C5 and goes to E, and from here also goes, this is E, and this will be C4. So it is D, it is B, like this. So here, this is a Wheatstone bridge in some different form. Again, if I have this sort of circuit, once again, so let me have a triangle-like shape here, triangle-like shape, and let me have this connection here, and here there is no connection, there is discontinuity. So let me fill capacitors here. Capacitor here, so this is capacitor, this is capacitor, this is capacitor, and this is capacitor. Now this circuit is also a Wheatstone bridge circuit. How? So let us do it. Let us fold it like this. Let us take it here. So it becomes like this. Let us take this whole thing over there. So it will be like this. So this is the capacitor here, and this is the capacitor here. So now we can take it like this, and this goes off. Now the only thing that we need to do is slightly twist our head like this. So if I see it like this, or if I twist it like this, it is exactly like this. So this is also a Wheatstone bridge, where the bridge circuit is this one. Bridge circuit is this one. So this is capacitor C2. As you dealt with here, it was C2. This will be C2, C5, C4, and C1 and C3. So Wheatstone bridge can take many forms. The only thing is that we have to recognize the Western Bridge in